Hello friends, welcome to Engineering Funda family. In this video, I'll give brief introduction to optical communication. In this video, I will cover three essential topics of optical communication. In first topic, I will discuss about historical development of optical communication. In second topic, I'll explain advantages of optical communication. And in third topic, I will compare fiber optic communication with copper wire communication. So let us start this video with first agenda, that is historical development of optical communication. Here I'll explain different generations of optical communication. Here I'll discuss about first generation, second generation, third generation, fourth generation and fifth generation of optical communication. If you talk about first generation, then that was there in 1980 to 1988. With first generation, data rate with single cable was 45 to 140 Mbps. And here we were been using multi-mode optical fiber. To fabricate fiber, we were been using impure silica. Here optical source was LEDs and early FB laser. Here wavelength of communication was 850 nanometer and repeater spacing was there from 2 to 10 kilometer. If you talk about key features, then with first generation, with cables we were been having higher losses, higher dispersion, and this first generation was suitable for short range communication. So with first generation, data rate was 45 to 140 Mbps. Here we were been using multi-mode fiber. Material was impure silica. Optical source was LEDs and early FB laser. And wavelength was 850 nanometer. If you talk about second generation, then that was implemented in 1989 to 1995. Here we were been having increased data rate compared to first generation. With second generation, data rate was 155 Mbps to 2.5 Gbps. Here we were been using single mode optical fiber and material with fiber was with high pure silica. Optical source was early FB laser and DFB laser. See, previously we were been using LEDs. Now we were been having distributed optical fiber laser. Here with second generation, wavelength was 1310 nanometer and repeater spacing was 40 to 50 kilometer. So now you can observe repeater spacing is increasing, right? And that is happening due to minimum dispersion. And this second generation, that was suitable for long range communication. Previously we need repeater spacing with 2 to 10 kilometer. But with second generation, now repeater spacing that is increased. Why? The reason is now there is minimum dispersion, right? See, in third generation, time duration was 1996 to 2002. Here data rate have increased to 10 Gbps. Here we were been using single mode optical fiber, that was long hole single mode optical fiber. Here we were been using ultra low loss silica with fibers. Here optical source was DFB laser and wavelength was 1550 nanometer. Here repeater spacing that have increased to 80 to 120 kilometer due to EDFA amplifier. And key features was, here we were been using EDFA amplifier and that is suitable for long range communication. See, this third generation, that is having higher data rate. This second generation, that we were been using with early GPRS technology. In cellular technology, we have been using GPRS and that was there in this second generation. With third generation, now data rate has increased, right? So with 3G technology, if somebody is using mobile phone, then there is bit higher data rate compared to GPRS that you can compare based on optical communication, right? The reason is with cellular technology also, backbone is there with optical communication only in cellular technology, but obviously tower is communicating with mobile as per wireless communication. But those towers are communicating with each other with optical communication only, right? If you talk about fourth generation, then in fourth generation, duration was 2003 to 2010. Here data rate has increased to 40 to 100 Gbps. Here fiber type was dispersion managed fibers. Material was silica plus dispersion compensation. See, because of silica and dispersion compensation, here there will be lower loss in transmission. If you talk about optical source, then we were been using tunable laser. If you talk about wavelengths, then here there were two bands. One is C band and second is L band. One should know this 1550 nanometer that belongs to C band, and if you talk about L band, then that is having range of 1570 to 1610 nanometer. Here repeater spacing that was there from 80 to 120 kilometer, where we were been using EDFA amplifier as well as Raman amplifier. If you talk about key features, then here there is dispersion management as well as it is suitable for dense wavelength division multiplexing as well as it is suitable for long range communication. After that, we were been having fifth generation that was initiated in 2011, and right now in 2025 also we are using fifth generation technology with optical communication. Here data rate is varying from 100 Gbps to 800 Gbps. Here fiber type is photonic crystal fiber. Here we are using ultra pure silica along with hollow core fibers. Here optical sources are coherent laser, and with this fifth generation we are using C band, L band and S band. If you talk about repeater spacing, then that have increased to 100 to 200 kilometers. Here key features are dispersion management, massive WDM technology, coherent laser and long range communication. So if you observe historical development of optical communication, then with respect to time, we are using different categories of fibers with different materials, and with fifth generation, you can observe we have highest data rate, and that you can feel with your mobile communication also. The reason is backbone of mobile communication is there with optical communication only, right? Now, let me discuss about advantages of optical communication. See, if you talk about bandwidth, then optical communication that is having very high bandwidth. Here you can have bandwidth from Gbps to Tbps, terabits per second, right? If you talk about losses, then with optical communication we have minimum attenuation. See, with 1550 nanometer wavelength, here losses are there as per 0.2 dB per kilometer. That's why you need repeater after hundreds of kilometers, right? If you talk about immunity to electromagnetics interference, then there is no EMI with optical communication. One should know with optical fibers, we are transmitting signal with the use of light. There is no electrical signal. That's why one can say optical communication is immune with respect to EMI. That is there with copper wire communication only, right? If you talk about security, then optical communication that is very secure. The reason is it is very difficult to tap optical cable without detection, and there is no electromagnetic radiation leakage. So here we have higher security in communication. Nobody can extract information in between, right? If you talk about size, then optical fibers are compact and it is lightweight. So optical fibers are thinner and lighter compared to copper cables. If you talk about distance of communication, then with optical communication, we need repeaters at hundreds of kilometers. Means one can have communication at hundreds of kilometers without repeater. So optical communication is preferred for longer range. If you talk about reliability and durability, then one should know fibers does not have corrosion, right? So there is a resistance to corrosion, moisture and temperature variation. If you talk about power consumption, then with light source, we need less power, right? If you talk about safety, then here we have better safety. Why? The reason is in optical cable, there is no electrical current. So there is no probability of shock. If you talk about support to WDM, then one can use multiple optical cables by which one can have WDM technology, wavelength division multiplexing, by which many users can access optical communication, right? Hundreds of wavelengths that one can use in single cable. Now let me compare fiber optic communication with copper wire communication. So here I'll compare fiber optic communication with copper wire communication based on different parameters. If you talk about bandwidth, then fiber optic communication that is having bandwidth in terms of terahertz, while copper wire communication that is having bandwidth in terms of megahertz. If you talk about distance, then fiber optic communication can be used for long range communication up to hundreds of kilometers, while copper wire communication that we prefer for short range communication, like if you want communication from 100 meter to 5 kilometer, then one can use copper wire communication. If you talk about loss of signal, then with fiber optic communication, we have a loss of signal as per 0.2 dB per kilometer, while it is quite large with copper wire communication. Here we have a loss of 5 to 20 dB per kilometer. That's why there is short range, right? If you talk about electromagnetic interference, then in fiber optic communication, signal will be light. So there will be no EMI. There won't be any electromagnetic interference. But in copper wire communication, there will be electrical signal. That's why there will be electromagnetic interference. If you talk about circuit size, then with fiber optic communication, we have compact circuit. The reason is here wavelength is there in terms of micrometer. While with copper wire communication, we have bigger wavelength. That's why circuit size will be bigger comparatively. If you talk about fragility, then with fiber optic communication, we are using optical fiber. In case of glass fiber, there will be fragility. So glass fibers are fragile, while copper wire are flexible in nature. If you compare that with respect to two cable connection, then there is a need of fiber splicing. And this fiber splicing that needs accuracy. While in case of copper wire, we can easily connect, and by having a soldering, one can connect copper cables, right? So connection is easy with copper wire communication, right? If you compare this with respect to cost, then for long run, cost is low, but initial cost of installation is high. While with copper wire communication, we have higher cost comparatively for long run. Initial cost of installation will be low, but for long run, there will be higher cost of copper wire communication. If you talk about applications, then backbone of internet that is executed with respect to fiber optic communication. But for small networks like local area network, one can go for copper wire communication. So that is how fiber optic communication have evolved with respect to time. And one should know nowadays almost entire communication on this globe is happening by fiber optic communication only. The reason is it supports wide bandwidth, and even if you use parallel cables, then there won't be any interference in between two cables. So if you increase the density of number of cables, then you can increase bandwidth relatively, right? While in case of copper wire communication, you will be observing if you have multiple cables, then there will be electromagnetic interference with each other. So that will be limiting bandwidth. So you will be observing almost entire internet is functioning with respect to optical communication only. I hope you have enjoyed this video. Still, if you have any confusion, just place that in comment section. I'll be happy to help you. Thank you so much for watching this video.